Linux is a multi-user operating system, so the file system needs to take into account that people will have different rights to different files and directories on the file system. When we do a listing of files using the ls-l command, you see on the left side a cryptic column filled with varying patterns of RWX letters. These are the permissions. Then next to that you see two rows of names. These are the name of the owner and the group for the directory item. So let's try to break this down a bit. So let's tackle the names first. Every time a new file or subdirectory gets created, it is tagged with the name of the person who created it as the owner. There is also a group assigned to the item as well. When a user is created, a group is made with the same name as the user ID. This is the default group assigned to the file. The owner and the group for the file can each be changed. We will cover that more in a moment. The listing of the permissions on the left are organized in three groups. So you have an RWX group for the owner, a second for the group, and a third is everyone. So the third group of permission covers anyone that has an account on the system. For files, the permissions are pretty straightforward. The R permission means you can read the file. So you could open, say, a document in your word processor or view a photo. The W permission is the write permission. This means that you can modify the file or delete the file. The X permission is the execute permission. With Windows, a program can run because it has an exe extension at the end. Well, that and it has to be an actual program. A batch file runs because it has a BAT extension. Well, Linux is a bit different. A program runs because it has the execute permission on it. And a script file, the Linux equivalent to a batch file, runs because it has the execute permission. They don't need a special extension on the file name. They don't even need any extension on the file name. So for the owner to be able to read and modify a file, they would need both R and W permissions. If the group has the R permission, then they can read the file, but not modify or delete it. If it is a program or a shell script, then if it has the X permission for the group, then the group can run it. If the owner, group, and everyone has X, then they can all run the program. Pretty straightforward, right? Subdirectories are slightly different. The easy part is if you want to read the directory name and what is in the directory, you need the read permission. But to be able to see that, you also need the execute permission. So, for our uses, just assume that directories will need both R and X for a user, group, or everyone to see the directory and what is inside it. If you want someone to be able to write new files in the folder, then they will need the write permission on the folder. Okay, let's look at adjusting things with the GUI tool first. I will open up Nemo on my home drive. You can see files and directories. If I right-click on a file, then select Properties, I get the Properties dialog box for the file. There's a tab called Permissions. When I click on that, I see the owner of the file along with a line item for access, the group that is assigned to the file along with access, and then others. Others is, of course, everyone. So there is not a name beside that. There's also a line for execute. One limitation of this dialog box is that you grant the execute right to all three groups or none of them. If we want to assign execute rights to the single group, then we need to do that at the command line or with a different graphical tool. When I'm using Nemo, I cannot change the owner of the file, another limitation of the tool. But I can adjust the permissions to the file with the drop-down list. For owner, I can only set it to either read-only or read-write. For the group, I have a drop-down that will list all of the groups, so I can pick one for the file. Then for access, I can set read-only, read-write, or none. Then the last access drop-down is for the others, or everyone permission. Again, I can read-only, read-write, or none. If I want to set the execute permission, I simply click on the box. Then I close the dialog box and it saves the changes. If I go to the command line, I can see that the rights have changed. Let's look at changing permissions on the command line. So I will open the terminal program and go to my demo folder. Now, if I do an ls-l, you will see a list of files. There is a file called hardwarelist.txt with read-write for the owner and read for group and others. So the command line command for changing permissions is chmod, or chmod. Let's allow the group to have write permissions. I type in chmod g+w hardwarelist.txt and press enter. Now if I do an ll, you can see that the permissions have changed to add write to the group. When you do the chmod, you can change for user by using u, or group using a G, or others with an O, or everyone using an A. So if I want to add execute for all users, I can type chmod a+x hardwarelist.txt and press enter. Now I will do ll again, and you will see that all three have execute. Now let's say I want to take execute off from other. I can type chmod o-x hardwarelist.txt and press enter. I do an ll, and now you can see execute has been removed from other. You can adjust the rights on multiple files using a wildcard in the file name. Notice that at the command line I have more control of the execute permission than I did in the graphical screen. So far I have adjusted rights on files I have access to, but there are times that you need to adjust rights on files you are not the owner of. You can do this if you have root access for the system. For Ubuntu-based distros like Mint, sudo is automatically configured to allow access to administrators of the system. So all you need to do is type sudo before chmod to use the command as root. This will give you full rights to adjust any file on the system. When you use sudo, it will ask you for your password. After the first time, you can use sudo without being asked for your password again for a period of time. For changing users, you will use the chon, or chon command for change owner. This is really straightforward. The big thing is that if I am the owner and I'm going to change to a different owner, I will need to do this as root. So I will need to use sudo. So if I want to change the owner for hardwarelist.txt to Bob, I would type sudo chon bob hardwarelist.txt and press enter. Now if I type ll and press enter, you will see that the owner of the file has changed. I can change it back to me now with the same command and my user ID. Since Bash has a history of all my commands, I can just up arrow twice and then change the username and press enter. Now I will do an ll and press enter to show the change happened. The command to change the group on a file is chgrp. The command structure is the same as chon, so I can type change group demo hardwarelist.txt and press enter. Now I do an ll, and you will see the group demo is assigned to the file. Now the chon command has an interesting little feature. You can actually change both the owner and group at the same time with chon. Let's set the file to Bob and the group to Bob. So I will do sudo chon bob hardwarelist.txt and press enter. Now if I type ll and press enter, you will see that both the owner and group have changed. If I do sudo chon rusty:\demo hardwarelist.txt and press enter, you will see that we are back to where we were before. All three of these commands work on subdirectories just like they do with files. With both chon and change group, you can use wildcards in the file names just like with chmod. So from the command line, you can adjust large numbers of files and directories quickly. You can see where the command line is much more efficient when dealing with large numbers of files. And on servers, the command line is most often your only option.